Hi guys. Okay, so Unit 4, projectile motion. Okay, so we have learning targets 1, 2, 3, and 4, and actually, just so you guys know, learning target number 3, we're gonna skip that one, and so we're just gonna be focusing on 1 and 2. Okay, so this first part here, our first learning target is to do with projectile motions. And so what we mean by a projectile is anything that's flying through the air, not under its own power, meaning that like it doesn't have an engine that's propelling it forward. Okay, that if I look at and I neglect air resistance and I look at the object, that as it's traveling through the air, the only force acting on that object at any point is the force due to gravity. And that's it, right? Like initially a hand pushed the basketball to get it going, but this is after the hand is no longer in contact with the basketball and the basketball's flying through the air. It's now a projectile because the only force acting on it is the force due to gravity. Okay? So first thing, let's describe the motion. It's always a parabolic motion, like a parabola. And so that's the type of curve that would be described. It's an object shot through the air. It could be anything. We should probably add also a second bullet point there that, like I said, it doesn't have an engine. It's not like self-propelled, okay? And so what forces are acting on the object in motion? Only gravity. And we do have to, in this course, and it really simplifies what we're doing in the math, that we're neglecting air resistance. Okay? And it does play such a small role for a lot of these situations. Okay, so drawing free body diagrams, those become really simple. Because again, like I said, the definition here of this projectile is that it's flying through the air and the only force acting on it is the force due to gravity. We're ignoring that air resistance. Okay, so we get this curved parabolic shape. We call that path the trajectory. And so let's see, we have 2 or more free body diagrams. One for the apex of the object's motion, and then a second for some time following the apex. Okay, so we'll say like this is our first one that we're looking at here. Okay? And at the very top of that parabola, the only force acting on that object is the force due to gravity, and that's it. And then sometime later, it's the same thing. The only force acting on that object in the moment is the force due to gravity, and that's it. Now, there was an initial force of the foot on the football to get it going, but the foot's no longer in contact with the football here or here or here, and so it could no longer be applying that force. Draw a free body diagram for forces on a projectile when it's at the apex of its trajectory. We just barely talked about that, right? Again, the big idea here is we don't have thrust, it doesn't have an engine, that the only force is the force due to gravity. Alright, so we're gonna skip the demo. Let me grab our next page of notes here. Okay. Now, a couple things that we can look at here. Notice that this is the path of the cannonball, okay? And the cannon is perfectly horizontal, okay? That initial velocity of the cannonball is all in the x direction, though there's no y component to it. And then we're talking about the initial velocity. And when I track in the x direction what's happening to the cannonball, and these are each 1 second apart, okay? I'm moving the same distance per second. So that must mean that my velocity is the same throughout the trip in the x direction. And so if velocity doesn't change, like let's skip down here, how does the horizontal velocity change? It doesn't. Okay, there's no change there. And so if there's not a change in the velocity, right? Reminder, acceleration is a change in velocity over a change in time. If the change in the velocity is 0, then we don't have any acceleration. So in the x direction, our acceleration is 0 meters per second squared. This should make sense, because remember, the only force is the force due to gravity. There's no forces in the x direction that would cause an acceleration. Okay? The sum of the forces in the x direction equals 0, and so that must mean that the acceleration is equal to 0. Now the y direction is different. We do have a force in the y. We have the force due to gravity. And so if we want to know what that vertical acceleration is, well, it must be the acceleration due to gravity, because there's no other component acting on that. So I'd say it's going down, so I'm going to say there's a negative 9.81 meters per second squared acceleration. So how does the vertical velocity change? It increases in the negative direction, right? These are all 1 second apart, and we're covering more distance per second. So we're increasing in velocity, but going down. Okay, so we'll increase in the negative direction. Okay, so a red ball is launched horizontally. So let's draw what this is our initial velocity there, okay? And it's going to have a parabolic shape, so it's going to come down, and eventually it's going to hit the ground. What forces are acting on the ball? The moment it leaves the table, that it's no longer on the table, that would be the force of gravity. What is the acceleration in the y? Well, that would be 9.81, because it's the acceleration due to gravity. How does y change? It increases in the negative direction. Acceleration in the x, remember from before? Our velocity is not changing in the x direction. And if we do not have a change in velocity, then we don't have an acceleration. So in the x direction, acceleration is equal to 0. And does the velocity x change? No, it doesn't. It stays the same throughout the entire path. Okay. And then this is just a summary of that if we want to break up the velocity into its x and y components, see how the velocity in the x always is staying the same, but the velocity in the y increases over time. Okay. Okay, so give this concept check a go, okay? And then we're going to actually go on from here, and we're going to start working on practice problems, I believe. Yeah, we're going to look at the kinematic equations again, and then we're going to work on practice problems. Let's see, where are we at time-wise? Okay. All right. So we're moving on to page 87 of our notes. Okay, so this is just summary and reminder of what's happening with that parabolic motion, that the acceleration in the x direction is 0, the acceleration in the y is due to gravity, because that's the only force acting on the object. Okay. Now, here are our kinematic equations. Okay. And I want us to focus on these 4, right? And this one only works if there's not an acceleration. Okay? And we're going to use these to identify and to process projectile motion questions. So here's our first one. A stone is thrown horizontally at a speed of 5 meters per second from the top of the cliff. a cliff that is 78.4 meters high. Okay, on every single one of these questions, every single one, I want you to draw a picture and establish an origin. And then after that, we're going to make our lists of knowns and unknowns. Okay, so if I were to draw this picture, a stone is thrown horizontally at a speed of 5 meters per second. And then we're at the top of a cliff, so we're going to have a cliff here, and then we're going to have a stone that's going to have a velocity initial that's all in the x direction. We're going to see a parabolic motion. Eventually it's going to hit the ground. And I'm going to choose the base of the cliff to be my origin. So I've drawn a picture. I've established an origin. The question says that the velocity initial is horizontal, so all in the x, and it's 5 meters per second. And that the height of this cliff is 78.4 meters. Okay. Now we're going to make the same list that we've been working with for a while. You need to memorize these, make sure you can look at each component. So we want to know x initial, x final, velocity initial in the x, velocity final in the x, acceleration, and then time final. Okay, so that's the same list we're going to make over and over again. We're also going to do it for the y. So y initial, y final, velocity initial in the y, velocity final in the y, acceleration in the y, and then time final. Okay. Something important to note, the time it takes for the stone to go from this height to this height, right, from here to here in the y direction, is the same amount of time it takes for the stone to go from here to here in the x direction. So if we can solve for time in one component, then we can also solve for it in the other component. Okay, based off of our image, let's see how much of these lists of knowns and unknowns we can fill out. If I chose this spot to be my origin and the stone is starting right here, as far as the x direction goes, I'm starting at the origin. Okay. X final, I don't know what the x final is. Velocity initial in the x, well, the velocity initial is all in the x direction, so that must mean that's my velocity initial in the x. Okay. Remember how the only force on these projectiles are the force due to gravity, and what we've reiterated a few times, that in the x direction the acceleration is 0. So that means we don't have a change in our velocity. So if we start with 5 meters per second, we're going to end with 5 meters per second. Okay? We don't know the time component. Now let's look at the y direction. The initial, if this is my origin, I am initially starting 78.4 meters above my origin. Okay. And when I end, I'm going to be at my origin in the y direction, right? So that'll be 0 meters in the y. My velocity initial in the y. This whole initial component was in the x direction. A stone is thrown horizontally at a speed of 5 meters per second. There was no vertical component to this. Okay, and so that must mean the initial velocity is going to be 0 meters per second. Okay. Here's another thought experiment that's commonly used. Let me check where we're at time-wise. Okay, let's talk through this thought experiment and then we'll go through the calculation. So, if I have two identical bullets, and then I put one of those bullets in a gun, and I hold the other bullet at the same height, and I'm pointing the gun completely horizontal with like the ground, completely parallel to the ground. I'm not angling up or down, okay? And I fire the gun and I drop the bullet. Which bullet is going to hit the ground first? Okay, so I fire and drop at the same time. Is the bullet that was shot out of the gun going to hit the ground first, or is the one that was dropped by the hand at the same height going to hit the ground first? And what we need to realize is that in the y direction, everything's the same. that in the x direction we provided more initial velocity here than